So this is going to be a very efficient video about how to solve general cubic equations. Yes, in the 1500s they invented an algorithm which could be turned into a formula, kind of like the quadratic formula, but a lot more complicated. So I'm not going to teach that formula, at least not for this general question. The answer to this question is going to be somewhere a little bit bigger than 4. But that's not the exact answer. It's some kind of irrational answer. So this cubic does not factor. Some cubics do. This one doesn't, and I want to show you how to solve them. Let's start with a special type of cubic. A cubic that has no square term. So there's no x squared in there. That is called in math a depressed cubic. And back in 1515, someone figured out how to solve those. Let's move over the 9x and the 28. So let's just say if cubics are in the form x cubed equals px plus q. So depending on what p and q are. And for this one, I'm going to give you a formula. There's a derivation. You can watch the other videos if you want to see the derivation. To do this formula, it doesn't take very long. You take q divided by 2, which is 14. And you also do q over 2 squared minus p over 3 cubed, which is 14 squared minus 3 cubed, which is 196, minus 27, which is 169. And the numbers that are going to be relevant to us are the 14 and the 169. They get put into an answer. Again, there is an explanation of this, but that's not what this video is for. This video is just to show you what the formula is. The answer looks pretty ugly. So the answer always looks like this. Before the plus sign and the minus sign, we put the q over 2. So we put 14 here and also here. Inside the square root symbol, we put that number. Now, sometimes you just end it right there, and that you say, there's my answer. It's exactly the right answer. But occasionally you get lucky. Occasionally the answer is like an integer, and square root of 169 happens to be a perfect square. That seems lucky. And the luck is just going to keep coming, because 14 plus 13 is 27, which is a perfect cube. And 14 minus 13, is 1, which is a perfect cube. So you get 3 plus 1 equals 4. And that is the depressed cubic. That's actually called nowadays Cardano's formula. He did not invent it, but it's named after him. If you're someone who really likes formulas, x cubed equals px plus q, you could say that the formula is the cube root of q over 2 plus the square root of q over 2 squared minus p over 3 cubed. And over here, it's q over 2. The only difference is there's a minus there. And this is a square. This is cube root, square root of p over 2 squared minus q over 3 cubed. So let's apply that to a question. For instance, x cubed equals 39x plus 390. 390 over 2, or 380, sorry. 380 over 2 is 190. 380 over 2 squared minus 39 over 3 cubed. It helps when this is a multiple of 3 and that's even, though it doesn't have to be that. Is 33903. And when you put this all together, you get your answer. Cube root of 190 plus square root of 33903. I think it's that. It might be 803. It doesn't matter. I mean, it matters for the answer, but I think that's an 8. That's a 9. This is a minus here. So the only difference between these two terms is that one has a plus here and one has a minus. If you throw this into the calculator, you get 9.0098. So you get ugly answers sometimes that don't simplify because the answer is usually irrational. A strange thing can happen when you run this through the formula. 40 over 2 equals 20. 40 over 2 squared minus 6 over 3 cubed is 400 minus 8, which is 392. And 392 is not a perfect square. So you have to leave it like this. But if you run this through a calculator, it actually equals to exactly 4. If you plug 4 into this original question, you'll see 4 cubed is 64. And 6 times 4 plus 40 is also 64. But the formula doesn't, it might give us an ugly answer, an ugly equivalent number that's equivalent to some integer. There's no way to simplify it. Okay, so that was part 1 of the video, how to solve depressed cubic equations. You may leave the answers in that form. If this thing just happens to be a perfect square because you got lucky, you can go ahead and simplify it more. But even if it doesn't simplify, there was a chance, even if this thing isn't a perfect square, there was a chance that the answer still became an integer. You never know. Most of the answers look like this. This one's irrational. This one looks just as ugly, but it's actually an integer. Now, what if the cubic equation is not depressed? It has all the terms. The trick is to replace the x. The number 1, the coefficient of the x is called a. The coefficient in front of the x squared is called b. The coefficient in front of the x is called c. And the constant is called t. So x is equal to y, always y minus b over 3a, which in this case is 6 over 3 times 1, which is, y minus b over 3a, which is y minus 2. You replace each of the x's with y minus 2. And if you're really careful with your multiplication, you need to practice multiply y minus 2 times y minus 2 times y minus 2. But you know what? This video is, why not just show you in case you're reviewing. So y minus 2 times y minus 2, you do sort of a distributive property thing where each term gets multiplied by each other term. So you get y squared minus 4y. If it helps you, I'll write minus 2y. Minus 2y plus 4, which is y squared minus 4y plus 4. Now, to get y minus 2 cubed, you can take that answer you just got. All right, y minus 2 cubed is y minus 2 squared times y minus 2. We just calculated y minus 2 squared. Parentheses, y minus 2. Distribute. There's going to be 6 terms because you have to multiply each term on the thing on the left by each term on the thing on the right. So you get y cubed minus 2y squared. That was that one. Then you do these two. Minus 4y squared plus 8y. And then finally these two. Plus 4y minus 8. So if you take this expression and you replace y minus 2 cubed with this expression, which actually simplifies to y cubed minus 6y squared plus 12y minus 8. Minus 8. Hold on a second. There was a 13 here. Where did it go? Oh, sorry. This is just the y. The cube thing turns into y cubed minus 6y squared plus 12y minus 8. That's just what this is. The 6y minus 2 squared, you have to multiply each of these things through by 6. If you multiply this by 6, you get a 6 here and a 6 there. If you put this thing all together, it ends up becoming y cubed minus 6y squared plus 12y minus 8 plus 6y squared minus 24y plus 24 plus 6y minus 12 equals 0. That's looking pretty ugly. Minus 12 and then minus 13. That 13 came from there. When you combine this, be extra careful. It will end up being y cubed minus 6y minus 9 equals 0. And that's not an accident that the squared term cancels out, because if you choose properly y minus b over 3a, you should always expect that the x squared term will cancel out. And what you're left with is depressed cubic. So we use the formula for that. We get 4.5 plus the square root of 12.25, if you run it through the formula, plus cube root of 4.5 minus square root of 12.25. So you think, oh, I don't like odd numbers. I wish this thing was even. But 12.25, when you take the square root of it, becomes 3.5. So this is cube root, actually becomes cube root of 8 plus cube root of 1, which is 3 plus 1, which equals 4. So 4 is the number that makes this equation true. But they didn't want that equation. They wanted to know what would make the original equation true. Well, remember, we changed x into y minus 2. So x is equal to y minus 2. So I come back over here. X is equal to y minus 2. I just figured out y, so I do 4 minus 2, and I get 2. And 2 is the answer to this original question. You could test it out. 2 cubed is 8. Plus 6 times 4 is 24. That's up to 32. Oops, slight error. Sorry about that. Cube root of 8 is not 3, but it is 2. So let me fix that. Oops. Equals 2 plus 1, which is actually 3. And so x is 3 minus 2, which is 1, not 2. And if you take x equals 1 and plug it into here, you will get 1 plus 6, which is 13, minus 13 is 0. So it does work. So here's one that doesn't have a nice integer answer. You replace x with y minus b over 3a. b is 15, a is 1, and you replace it with y minus 5. You do that in all 3 places. There are some shortcuts for expanding y minus 5 cubed. You don't really need them because you're going to be doing y minus 5 squared anyway. So it's only one more sort of series of steps to get to y minus 5 cubed. But I'm just going to go dot, dot, dot. This will turn into y cubed minus 39y minus 380 equals 0. Or y cubed equals 39y plus 380. 39y plus 380, I have seen that before. I throw it over here with x. So it was 190 and 33,903. So y is cube root of 190 plus the square root of 33, 803, or 903, plus the cube root of 190 minus the square root of 33,903. I just verified it is 33,903. Now that number is a little bit bigger than 9, but it's not equal to 9. So we leave the answer for y as ugly as that. And for x, according to this, x was replaced with y minus 5. So the answer is just going to be this ugly thing. With a minus 5 at the end. And that's going to be approximately 4.0098. But you are permitted to leave the answer like this. You're also permitted on the homework, although it is good practice, to type this into something called Wolfram Alpha. You could say simplify. You type that, and you type in this big thing, and it will turn it into that for you, just to check that you got it right. Okay, I did it all in 16 minutes and 45 seconds. That's what you need to know for the final. There are much lengthier videos, like an hour and a half worth. This could have been a whole 3-hour day explaining all these formulas and why they work. But that's not the purpose of this video. This purpose is just to show you what you need to know for the final and for the homework.